In this video, we are going to discuss average acceleration. Acceleration is a vector quantity, and if there is a different word for the scalar quantity, I'm not aware of it. I don't think acceleration can actually be a scalar quantity. Acceleration is defined as the change in velocity with respect to time. In equation form, that would be, so we're using A to represent acceleration, and I've drawn my vector arrow because it is a vector quantity, and I'm using a subscript for average because we're not talking about, at this particular moment, knowing whether or not the acceleration stays the same value the whole way through the motion. So this is going to equal the change in velocity, remember that delta means change, with respect to time. So this is going to be V final minus V initial over T final minus T initial. Now keep in mind, final and initial is not the same as average. Final and initial are at specific points in the motion. They are not the average motion. Our units in this case are going to be velocity units, which were meters per second, divided by a second. And this reduces to meters per second squared. Once again, we're going to look at the slope, but this time we're going to look at the slope of a velocity versus time graph. So slope is still rise over run. But our rise in this case is going to be the change in velocity. So we're going to look at position 1 versus position 2. And we're going to take the change in velocity between the two. And then we're looking at time 2 minus time 1, or the change in time. And this should look familiar because it's equal to the average acceleration. And so once again, as we go through the graph, the slope here is not the same as our slope down here. So that means the average velocity from here to here and here to here is not going to be the same value, or that our acceleration is not constant the whole way through the motion. So this here is going to represent non-constant acceleration. But if we look at this graph over here, 1 and 2, this gets you this slope, and 3 and 4 gets you this slope. This here is constant acceleration, meaning that the acceleration stays the same the whole way through the motion. Now, both constant acceleration and non-constant acceleration leads to a change in velocity, meaning that the velocity initial and final are going to be two different values. However, the difference between the two is that this one has the velocity change at a constant rate, meaning that every second you're going to increase a certain number of meters. Versus non-constant acceleration, where the number of meters you're increasing per second is not always the same value. So it's the change in velocity that is affected, the rate at which that velocity changes. They both lead to the velocity either increasing or decreasing with time. It's just at whether or not that rate is constant or not. The difference is pushing on your accelerator at a steady pace versus pushing really fast and then slowing down. How you push on your accelerator, which is why it's called an accelerator, affects how you change the velocity of your vehicle. Now, let's focus in on our last line here, our horizontal line. Once again, if we look at the slope between this point and this point, there is no rise, so your slope is going to be 0. So this line represents 0 acceleration. And that's going to be very important. 0 acceleration means that the velocity is constant. it's going to be the same value initially as it is finally. The value of the velocity is not changing. And that's going to be very important in the wording of problems, because if I say the velocity is constant, you know the acceleration is 0. Or if I say the acceleration is 0, you know that the initial and the final velocity are going to be the same values. Now, when we talked about velocity in the prior video, velocity can be negative because it's traveling in the negative direction, and it's positive when it's traveling in the positive direction. Acceleration, on the other hand, can be negative for two different reasons. You can have an object accelerate in a negative direction. You can also have an object decelerate, meaning that the velocity is decreasing in magnitude, so that when you do your change of velocity, you get a negative result. When we discuss free fall, I'll give you an example of both of those. But remember, acceleration can be negative for two reasons. One, you're accelerating in the negative direction. The other is that you're decelerating, or the velocity is decreasing.